Hi, it's Virginia, and today we're talking to Hamish from Pump. Welcome, Hamish.
Hi, thanks for having me. So we operate in the testing space for contact centres. We do load testing and regression testing and health check monitoring.
Yeah, so for the people that don't know what that means, if you're a big company, he can help save you a lot of money by working out whether your call system's working or not. So before we get started on how the technology actually works and a walkthrough of it, we just want to go behind the scenes and ask you, how did you come to do Pump?
Okay, so I've been working as an engineer in the contact centre space for about 15 years, mainly within Australia, but to a degree throughout Asia. And during this time, we always struggled a lot with our testing. Initially, there were no real test tools that we had to operate with at all. And we did a lot of our testing manually. So as we were creating systems, we would dial into the system and see how it was performing and do very targeted testing.
Is this for like thousands of calls at a time?
No, this is like one call at a time.
Okay.
So we could prove that
Very
it appeared
grand.
to be functionally working. And then there was always an element of doubt when we turned the systems on in anger. So we would be fairly confident that our individual pieces worked, and we felt we'd done enough testing, dialing in to ensure that the system would probably work. What we had no real idea about, though, was from a load perspective, would it work? We knew it would work quite well with one or two calls. I remember a few times during deployment having all 100 agents or 200 agents dial in at the same time and seeing how that went. But, you know, that was the morning that we were going live, because that's the first time we had all the customers there. All of the agents there. It was all a little bit scary initially.
Yeah.
So then after a while, we started, I worked on a few projects that used a testing tool, which at first we were really excited about. However, it became pretty apparent quickly that there were a lot of issues that we were coming across trying to test. And those issues were quite varied. And I came at it from a particular focus of, as an engineer, I wanted to make sure our environment was actually working. I'll talk through some of the issues that some of my colleagues had around pricing and scheduling and whatnot. But purely from an engineering point of view, there were often parts of the system I wanted to be able to test, and I was unable to test because the tools we had were incapable.
So you could only really test individually the little bit that you designed, not the whole phone system.
Yeah, and then even with that bit, we could only test certain parts of it.
Yeah.
And so we constantly were forced to spend significant time and effort around the outside of the testing, trying to analyse the results we were getting out of it and trawl through our own system logs a lot to actually understand the system performance. And this just struck me as crazy, and that we should be able to do better. And then there were parts of it which we just couldn't test. So technically there were some issues that we couldn't easily overcome. And then there were some real bugbears in that with these systems, although they were great at doing load testing.
What's load testing?
That's where we dial, maybe 1,000 calls at the same time, or 20 calls a second, whatever. Testing the system to the point where you expect it to start playing up.
Yeah.
Or at least to the volume at which that it is being designed to handle.
So deliberately breaking the system.
Yeah, normally within load testing, you push the environment you initially start at the volume that you expect, and then you might start to think about what people term avalanche volumes. So imagine you're a financial institution. If their ATM network went down, they will suddenly get a lot more calls, and they refer to this as a call avalanche. So testing at that volume. And then once you've gone past avalanche testing, if it still hasn't broken, then starting to poke it and prod it and see how far you can push it until it actually starts to fail.
Yeah.
And when what's really interesting about the failure point is being able to not only see that it failed, but also be able to recognise what the system's actually doing as it starts to fail. So then once you see that behaviour in production, you go, oh, I know what's happened. We're starting to fail now, not, that's a bit strange, we're getting a few calls doing this.
Yeah.
So being able to recognise when your car is running out of petrol is a good thing. So same for telephone.
It's like having a fuel gauge.
Perfect. So that's load testing, and during the load testing, we often struggle to actually be able to retrieve the data we needed to understand when we had calls failing, we may be seeing 20 calls a second, and the tool we're giving it can say, okay, 4 calls failed over that 1 second period, but we weren't able to differentiate between those 20 calls that appeared in that 1 second. And even worse, the clocks between the test system and the production system weren't synchronized. So it's not only 4 seconds, maybe it's 5 seconds. Oh, not only 1 second, maybe it's 5 seconds. So that's not 20 calls, it's now 100 calls.
So it would make it very difficult to find them in the logs.
Absolutely. And then maybe the calls take 2 or 3 seconds to arrive over the network. So it's actually 8 seconds and 160 calls, and I don't know how many times I went through and looked at 160 calls to try and work out which one was the one that failed. And I just struck me as we should be able to do better. We should be able to have end-to-end call recognition, where if we place a call from the test engine, we can identify that call as it hits the platform and say to the people who have constructed the system, we failed, and here is your call that failed.
And so, can you do that?
Yeah, we absolutely can.
Oh, good.
So we can hand them a call recording, a network trace, and say, and this is the call ID on your side for that call, which turns it from a half-day activity to go and look for this call into a 5-minute activity.
That's fantastic, isn't it?
Yeah,
so,
that was a great thing. And then some other silly things we found in that. Often when you're testing and you're looking at response times, that's one of the big things that you test for under load, is how long is it after you are dialed into the system and you press 2 before it comes back with the next prompt. Now, before it comes back with that prompt, it may, in certain course flows, have to go off and make a back-end call to a system and look up at account balance or verify whether your mobile phone's still active.
Oh, and how long it is between the response time and when it comes back.
Yeah. So that happens behind the scenes. So you press 2 and you expect as a consumer that you're going to have a response back within about 2 seconds. That's the guideline for accepting responses from pressing a number on your keyboard. In that 1 second's a bit too short and people haven't got the phone back up to their ear. 2 seconds is about right. If you get to 3 seconds, then people are starting to pull the phone away to make sure they really press the button. So you've got 2 seconds is the Goldilocks period. It's often in testing, you really want to understand the responsiveness of the system, and that is code for I want to see a response at around 2 seconds. With this other tool we're using, although you could say, okay, we want this response time, and it could give us back a percentage match, what it couldn't do is tell us what the spread was. In that, we chose 2 seconds rather arbitrarily. Whether it's 2 seconds, 1.8, 2.1, doesn't really matter. What matters is the ones that miss are actually 4 seconds or 8 seconds or 10 seconds. Then suddenly these become very relevant.
Yeah.
And we had no idea, and we were unable to get out this test tool that was being used, what this spread looked like. So short of running 10 tests and doing 1 at 2 seconds and 3 seconds and 4 seconds and 5 seconds up to 10, you had no idea what the spread was.
Yeah.
And that's very bad. And while they can run the same test with us, pull out the spread, then go in, click on any individual call and pull it straight back. And straight from the report, they can drill right down to the individual call and immediately come out, get the call recording, the network traces, the ID, and drive down and immediately start to identify what's gone wrong with that call.
So instead of having to test at 1 second, 1.8, 1.2, 1.3, that sort of thing, you could just do it once and it would tell you all of them.
Yeah.
Oh, that's great.
And so, and that was one of the big bugbears we had. So instead of relying on the reports coming out of the test tool, we were constantly actually going through our own environment, processing logs for the entire test run, and reconstructing what the report should have been, so we didn't have to run the test 10 times. And that just, to me, struck me as ridiculous.
Yeah. It's like plotting a graph.
Yeah.
Plotting your own graph.
And we could talk. We talked for a long time about some of the other problems which we saw technically, but from a background perspective, there were quite a number of technical issues which were getting in the way of our testing. And when they get in the way of your testing, well, what's that mean? It means you have to rerun the test multiple times, or you come out without adequate results to actually be confident that the system's working.
So they weren't statistically relevant results because you could only do one little bit each.
Yeah, and we only had so long to test.
Yeah.
And every time we had to rerun a test, well, that was more days.
So how long, in the old days before your system, how long would it take for a typical test?
Okay, so...
For a load test.
Yeah, so when we were talking about load testing, they would generally run over 4-hour periods. However, this drew another problem to us, in that every time we booked the 4-hour period, we had to agree time not only with our customer, who we were building the system for, but also with the test provider to get a 4-hour window on their side. And each window we asked for, we had to pay for. And the problem was, if anything went wrong, then we would have burnt our money, we would have lost our time slot, we would have lost our night of testing
with the customer. Time.
Yeah, normally load testing's done outside of hours in systems. Even if the system's not in production, the networks and the data labs and everything else are all production data labs, and so you've got to...
so what time in the night are we talking, the 4-hour test? Is this like past midnight?
To start testing, it's hard to do it with most customers for about 10 p.m. and you normally have to be all done by 6 a.m. So that gives you 2 windows there, one from 10 to 2 and one from 2 to 6.
And how many people do you have to have?
Well, that was the trick.
At 2 to 6 a.m.
That was the rub, so as to say, because it was so expensive to get our hands on the test system, and because we didn't want to delay our project even further, then we found ourselves quickly having to stand up whole teams for testing, even though in an ideal sense there may only be 2 people involved, one from the company doing the testing and one from the vendor or from the end customer, making sure that everything appears okay.
But then why would you need other people there?
Because if anything went wrong, we were spending so much money and having so much difficulty getting these windows, we didn't want, if anything went wrong, for them to be a showstopper. So we were actually having to stand up essentially almost the entire team to be ready, just in case it was a problem with the application layer or the database layer or the network layer.
So how many people's in a team?
We were often standing up the best part of 20 people for a night.
And so you had to pay, so instead of having your product that does the same test in what time? How long does it take?
Well, the test windows are 4 hours for load testing normally.
And how long do you spend now with your product?
So when we're actually executing, you execute over the same period of time. So you normally run a load test for at least half an hour, but anywhere up to 4 hours.
Yeah.
Instead of doing that with 2 people, whenever we wanted, we were trying to get constrained to these fixed 4-hour periods and standing up a team of 20 people.
And so now you can do the same thing in half an hour.
Well, yeah, so now using our tool, we can actually start to see the results a lot more quickly, and we can fine-tune the load as we're running.
Yeah.
So that was another annoying thing, is that you'd be running along at a set load and want to change something, and we'd have to stop, go away for an hour while the engineer sat there and pulled levers and pushed buttons that we were unaware what they actually did. And to us, it struck us as pretty simple, you know, we want to decrease the...
Oh, so you didn't know what load they were doing because you weren't allowed to do it.
Yeah, we were unable to drive the tool.
Yeah.
And so they were driving the tool, and it seemed to take an enormous amount of time to reconfigure it while with pump, one of our real design intents was to, firstly, it should be painfully simple to operate. And, we were awfully cute during design and said that we wanted our 6-year-old children to be able to drive the tool. And
do you want us to test it? Because I've got a 6-year-old.
Oh, we can. And we patted ourselves in the back and said how great a job we did, because a 6-year-old could sit there quite happily clicking on the buttons and watching the graphs go past. We were being a bit cute in that, although a 6-year-old...
So in other words, they can dial up the load and see the graph, is what you mean?
Yeah, so we can change, while it's running, we can just sit there and turn the dial up and down to make it test the system harder and softer. And that's really great when you want to do these tests where you start off testing at the intended production load, then dial it up and test at the avalanche load, and then dial it up a bit further and just keep dialing up, notching it up, notching it up, notching it up, until you start to see failures. Yeah. And we can recognise those failures quite quickly through our interfaces, saying, we're starting to see failed calls. We can give IDs. People can write off and start checking these calls while we're live. And then once we see, we're definitely struggling, then we can turn the dial down a bit and see, does the system recover after it's started to see load problems, which is a very relevant thing, and that you need to understand in a production environment whether once you've exceeded the load, what you have to do to make it work again. Do you have to reboot the thing, or if you just ramp back the traffic, does it break? Okay, does it get better? You ramp back the traffic, gets a bit better, ramp it up, does it break again? Yep, okay, so that's the point there. We can do this many calls per second. Okay, let's do a different sort of test and pull out those test cases, put in some other ones and say, is it something about the total number of calls rather than the number of calls arriving per second? Yeah. And try and understand what it is about your load that's breaking the environment, so then you can either see whether, that's the limit, or is there something we could do there? And the vendor will go away and say, if we put in more of this type of component, or we change the setting, it all gets better. Yeah. And we can pre-run this testing.
You mentioned before about this is the load testing.
Yep.
You said there were some other products. What is regression testing? Because you've mentioned that before. What is regression testing?
Okay. Yeah. So when we first started doing the automated testing, we were using it for load because that was something which is just infeasible to do in without having 500 people all sitting there ready to, or 1,000 people all sitting ready to dial. That's not feasible. So that sort of testing was infeasible to do without a tool.
Yeah.
The other sorts of testing you do, the one really major one is regression testing. That's where you have, instead of maybe 5 test cases, which you're running multiple instances of every second attempting to prove changes in behaviour, instead you may have 1,000 test cases. And what these 1,000 test cases are attempting to do is prove that your entire environment is working. So being able to go through all the different menus, enter into different queues, talk to different backends, and make sure that if your 1,000 or 2,000 or 500 test cases all pass, then your system should be operational. And so this is called regression testing, and it's really important in so many ways. Initially...
Like, who needs to do regression testing, and how often would you need to do regression testing?
Okay, so regression testing, one of the ways you can use it is during changes. So every time your people who reconfigure your system come in and do any work, and imagine they add a new queue in, or they change the messaging on the IVR, or they change the way the SMS is being responded to, we can rerun this entire test set.
Oh, to make sure it works.
To make sure it all still works, and to make sure the system didn't change the way it responds to you. So ideally it should be working. So if it was working, passes these tests, you're still confident it's working.
And then when would you use the load testing? What's the point of the load testing?
Okay, so load testing people use in a couple of ways. After they've done any major upgrade or reconfiguration of their environment, or release some new code, people often do load testing to make sure there's been no degradation of performance. Definitely during new deployments, people always want a load test. And then a lot of customers who have any sort of regulatory oversight, and this is very important for power companies and the like, to ensure that nothing's gone wrong within their environment to affect their telephony and their contact centre. And things that go wrong often aren't easily relatable back to the contact centre, in that there might be some new router put in some data centre somewhere, which is in the middle of your pipe, and you don't even don't know there's been a change. Yet, and during everyday performance, that's fine. But taking the case of a power company, when a storm rolls through, and they suddenly have this avalanche, and there's people trying to ring them who are desperate, have no power, potentially have health concerns where they need power to keep their life-saving equipment.
National emergencies.
Or people have life-saving equipment that needs to be on, and suddenly they don't have power and can't ring you because you haven't tested your environment. That's a real issue, and that's why these organisations, either externally or internally, mandate that they have to have regular load testing.
Your system's faster than anyone else's. So if there was, like, say, a storm approaching within, 2 days, so you got 2 days.
If you saw that there's a hurricane forming out at sea, which is going to hit, they could do an impromptu load test.
Because your system is cloud-based, could they do a load test really fast?
Yeah, they could stand up and do a load test straight away. So, with regression testing,
you could literally save people's lives with it.
Yeah, so with an impromptu load test, we could configure one and run one extremely quickly to ensure that the system is working. But occasionally you'll also want to run one in an unexpected fashion. So we had a real example with a financial services institution who we do some work with, where they realised there was going to be some database modifications occurring, and these had to happen quickly, and they were struggling to find a time window to do these outside of hours. And the question was asked, well, could they be done within business hours? By having a tool like Pump there ready to roll, they could immediately run a load test within a non-production environment and perform these changes, and then take that outcome into account when they were doing their planning to say, well, should we be doing this in production or not?
That's awesome. And then what about the health check? That you mentioned a health check as well. Well, how does that work?
Okay, so health check is the other extreme from load testing. With load testing, you're testing under extreme load. What happens now if we get completely overwhelmed by traffic? With regression testing, we're ensuring the entire environment's working, but again, this is done periodically, but a lot less frequently. So potentially after changes, or potentially daily at 6 a.m, making sure the entire environment appears to be good, ready to roll for when our customers start calling us in 2 minutes. The third sort of testing is a health check testing. And this is where you may dial into the system every 5 or 15 minutes. One call across each line of business, so maybe 10 calls every 15 minutes. You do this day and night, whenever the contact centre should be operational.
So it doesn't affect the rest of the contact centre? No.
Absolutely.
So you can do a health check anytime.
And so we do very low volume testing continuously, and then when these start to fail, we can retry the testing and alert on the results. So we can put up a wallboard with all the results, but wallboards are great, but no one really looks at them. Depends on the organisation. So we can also send the failures, because you want to know about them straight away, via SMS or email or SNMP traps, so that they become aware of this. And a lot of people, especially if they operate as a bureau within a larger organisation or as an outsource provider, they want to know that they've got a problem before their end customers are ringing them up saying, hey, this contact centre we're paying your department to run is not working. How can it be? They want to be on the front foot, so at least they can get the notification out to their customers, or they can resolve it, hopefully, before the end consuming business unit has discovered there's a problem.
So they want to get a health check before the customers ring complaining.
Because normally when things go wrong in a contact centre,
Yeah.
it's not always immediately apparent there's a problem, and that if maybe 5% of your calls are being hung up on or not answering, then those customers, 1 in every 20 callers, then they call back. Most of them will call back, get through and think, I probably dialed the wrong number.
So you need to get a certain complaint level before you even find out about it.
And then some of the people, when they call back and will say, that's a bit weird, I didn't get through, and then that may happen to a second time to that agent, and the agent thinks, there might be something wrong, and leans across and speaks to the person next to them and goes, hey, is something going wrong here? So low-level incidents can bubble along for quite a while, affecting your end customers and affecting the professionalism and the view they're seeing of your business before you even realise there's a problem. Well, if you've got active monitoring going on with health check or whatever term you want to refer to it by, these issues can be detected a lot more quickly.
Yeah, that's great. So you've got the health check, the monitoring and the regression testing. And then with those three, are they all the same sort of pricing, or I imagine the load testing would require a lot more infrastructure, wouldn't it?
So from our side, they're all, they are differently priced.
Yeah.
It's all the same product, it's just differently priced and configured, and then the amount of resources we have to throw at the platform to test it.
And how big would you have to be as a contact centre for this to be worthwhile, for where they do need to test it and that sort of thing, where they can't just ring the number themselves because there's only 5 people?
So it actually happens to remarkably small contact centres. For smaller contact centres, it's really useful because the calls are quite infrequent, so the health check becomes a lot more important. In that, if you're a little consumer who only gets a call every half hour on their number, and you don't get a call for 2 hours, you may just think, that's a bit unusual, I didn't get called, but you don't realise it's because you've been down for 2 hours, unless you happen to think, that's a bit strange, and pick up the phone and try and dial it. And if you get through in that instance, maybe you're okay. While once you get a bit more complex, then you're more likely to pick up the health check issues reasonably quickly, in that you've got a high enough call volume that people will start to complain. So after it's bubbled on for a while, you will realise it's an issue.
But again, you're finding out by complaint.
You're finding out by complaint. You're finding out by poor customer experience. You're losing sales revenue, or you're losing your ability to service your customers. There's all kinds of bad things about it.
So how small is too small to, what sort of size company would your product be aimed at then? Would it be?
Ideally, most of our customers are about 200 seats and up. But even if you go right down to that small 1 or 2 person operation receiving very few calls, then a health check monitoring is most definitely still available to them. But ideally, we targeted at the large...
Sort of large multi...
the medium to large contact centres.
Yeah. And the companies you have already are mostly large, aren't they?
Yeah, so...
They're government.
The companies that we tend to deal with have large contact centres.
And they're top 50 companies.
Banks, top 50 definitely. Banks, insurance companies, government departments, power companies are our bread and butter from a normal customer we deal with.
Yeah.
And these can be spread across both people who have on-premise solutions and cloud-hosted solutions on their side. And of course our equipment, although we're cloud-first and predominantly delivered through...
So you're cloud-first?
Yes.
Yeah.
However, when we have a customer who, for various reasons, security and whatnot, want to deploy our software on-premise, it's the same software that gets deployed, it's just a premise installation.
Yeah.
And that's pretty standard from our side.
Well, that sounds really interesting. And so if one of these companies wanted to do it cloud-based, how long would it take to get going with it?
Well, that's a great thing. So from a cloud perspective, it's there, it's running. All we have to do is some configuration to enable a new tenant onto our environment and provide them the access details. And one of the other great things about our software is the simplicity. And, we joked about our 6-year-olds earlier. But what we want is for our end customers to ideally be able to use and configure and create test cases and run reports and analyse the results without speaking to us.
Oh, so they do their own test cases.
Absolutely.
Well, if a 6-year-old could do it and you can do it, can you show me how to do it?
Sure, let's do that in a minute. But
it's a bit cheeky, isn't it? But we'll get it.
Initially, we assumed that we had to be intimately involved in all of the testing that's going on.
Yeah.
However, we found pretty quickly that in any test environment we went into, we never, at the end of the initial lot of testing, which may be a week or a day or whatever, when we went away, if it was an instance where the software is being left on site, we've never actually had a situation where the end customer was incapable of going in, updating the test cases and rerunning new reports. And this took us by surprise a little bit at first, in that we thought it was pretty simple and easy and straightforward, but we still assumed that we would be involved in the professional services, and various parties were excited about that. But to me, it was actually awesome that we weren't, because it was one of my original design intents.
Yeah,
and this
to
is
make it
because,
so that the engineers can do it themselves.
Yeah, and the reason you want to do this is, firstly, there's a commercial thing. If you don't want to pay expensive test resources to come in from Pump to come and do your work, when you could use your own internal resources, which are already there.
Your 6-year-old?
Well, you're a 6-year-old. But also, you've got the massive agility bonus of being able to do that. In that, if you discover there's something that needs to be tested now, you can sit down, write a test case, and have it tested 20 minutes later.
I'm going to take you up on that.
Yeah, good.
So why did you call it Pump? That's like a weird name, don't you think?
Have you been set up to ask me this question? Okay.
Yes.
So, we initially were referring to the product as the test tool, which didn't strike us as a great name. So we had to come up with a development name for the product. So just like Windows, maybe when Microsoft are developing it, comes across with, I think Windows XP was Longhorn or something, we had a development name for Pump, for the test tool.
And what was it?
Well, we had to come up with one. And I was racking my brains as I was busily coding and working away, and I'd had it one day, and I went for a walk, and I'm walking towards one of our customers, and I'm walking down the hill, and I'm coming down a flight of steps, and I looked up and I saw one of my favourite pubs, the Pump House. And I thought, Pump. Yeah, that'll do. That's a great development name to know it by, until our marketing folk come up with a real name that's all professional and sounds great. And so we started calling it Pump, and everything was great. We had all these internal meetings. And then when we were just coming out of the development phase, we had a working product, which was pretty good. And we're at the stage where you normally start coming up with marketing terms. Unfortunately, our friends with our team, we responded to a couple of RFPs, and we actually won a deal. And in these RFP responses and in the deal which we won, it was referred to as Pump. And so suddenly we had a product which had been sold, was out there in the market, and people were talking about it. It was called Pump. By that stage, it just became, the name had stuck. So here we are, 5 years later, with this product called Pump, still going strong, and focusing on all the big things, like coming up with all these great new features, and ensuring that we're on top of all the testing we wanted to do. Maybe one day we'll come up with a different name, but until then, you're stuck with Pump and pump.cx. Thank you.
Good.